Hey everyone, welcome back to Complete NumPy Series in 2025, and today we are going to cover the concept of mathematical operation in NumPy. We are going to see how we can perform addition, subtraction, multiplication and division on NumPy arrays, and we will see two different ways of performing each operation. We are going to see a very important concept of broadcasting, and make sure you at least watch the broadcasting part of this video because broadcasting is a very simple yet very powerful concept which is used in NumPy. These whole concepts are used in data analysis, machine learning, scientific computing and data science. Also, I am going to cover a bonus concept for you guys, and this is a practical concept which is used in data science, and we will see how we can implement that concept in NumPy in the last part of this video. So make sure you watch the complete video, and let's just jump in our code editor and start writing our code. So I am on my VS Code and we have a program already created. I have imported NumPy as NP and I have created two arrays. Both are NumPy array and we will perform mathematical operation on this array. First, let us see how we can perform addition of two NumPy arrays. So if you have a Python list, how do you do it? You might be using a loop, right? But we do not need to use any loop on NumPy. We can directly use the plus operator and perform the plus or addition of two or more NumPy arrays. So let us see the first way, number one, that is the first way, and output will be a1 plus a2. And this is how simple it is to perform addition in NumPy arrays. And let us see the second way as well. We will print the values of both the ways. So second way is you can use the built-in function which is there in NumPy. So you can say np.add, and inside this add method you can pass your NumPy arrays. So let us say a1 comma a2. Okay, so if you say np.add a1 comma a2 or a1 plus a2, both are going to do the same thing. It is going to add the elements in both the arrays, and how the addition will perform, it will be performed index wise. So the first index, which is actually the 0th index, will be added to the 0th index. The first index will be added to the first index, the second will be added to the second, and the third will be added to the third index. So let's just run the code and see the output. So the output is same, which is 5, 7, 13 and 16 in both the ways, because 4 plus 1 is 5, 5 plus 2, 10 plus 3 and 12 plus 4. So this is how you can perform addition. So we now know how to perform addition. Can we perform subtraction, multiplication and division as well? Well, we can. So let's copy the code for subtraction. So it will be subtract and number one, and we will just change plus to minus. And also what we can do is we can copy this to see the second way. So we can say np dot subtract a1 and a2. So let us just run the code. First change the method to subtract. Alright, so we will say a1 minus a2 or np.subtract a1 and a2. So let's run the code again. First clear the console and run it again. So you can see for subtract, we are getting the output as 3378. So 4 minus 1, 5 minus 2, 10 minus 3 and 12 minus 4. So this is how you can perform addition and subtraction. So for multiplication, again, let's just copy the code and perform multiplication. So I think now you know the concept. I will just say multiply and the number one way and multiply for number two. All right. So for the number one way, just say a1 into a2, which is a1 star a2, or np dot multiply a1 and a2. Let us clear the console again and run the code. And for multiply, the output is 4, 10, 30 and 48, which is like 4 into 1, 5 into 2, 10 into 3 and 12 into 4. And we can perform division as well. So we will say div and div, and to perform division you can say forward slash, which is the division operator, or you can call the method called as divide. So let us run this code again, clear the console, run the code, and for division you can see the output is same, which is 4 dot 2.5 dot 3 dot 333 and 3 dot. So this will be like 4 divided by 1, 5 divided by 2 10 divided by 3 and 12 divided by 4. For division, we have one more concept. You can just use double divide operator to get the integer value instead of decimal values. And to achieve the same using the second way, that is the built-in method way, you can call the method floor divide. Now this will perform the same thing what this double divide operator will do. It will divide the elements of A1 from A2, and the output will be an integer. So let's just run the code and see. So in this case, for division, the output is 4, 2, 3 and 3, and the method which we are using is float divide. So now you know the concept of addition, subtraction, multiplication and division in NumPy. Let us just jump on the next concept, which is broadcasting. So before we start the concept of broadcasting, what if we do the multiplication, division, addition or any mathematical operation on an array with a single number? For example, A3 is 10, which is just a single number, right? And we have an array. So if we perform the same operation, what will happen? So let us see. Let us print A1 plus A3. So I think you can guess the output. 10 will be added to each element, right? So let's run this code and see. So yes, 10 is added to each element. 4, 5, 10 and 12 became 14, 15, 20 and 22. So how this happened is with the concept called as broadcasting. So broadcasting means expanding the elements of smaller array to match the elements or size of the bigger array. To be precise, the shape. So the shape of A1 is it has one dimension and it has four elements in its first dimension. A3 is like a single element which you can imagine as a single dimensional array with one element. So if we say np.array and make it an array of one dimension and one element, the output will remain same. So what's happening when you're performing the operation, the smaller array A3 is broadcasted to match the size of the bigger array. So if you're writing A1 plus A3, it is like adding 4, 5, 10 and 12, that is A1 to 10. So in this case 10 is the smaller array, so it will be broadcasted to match the shape of the bigger array. So 10 comma 10 comma 10 comma 10, this is what exactly happens in the background, and after you add these two elements you will get this particular output, right? So it is a very simple concept. The smaller array will become or will be broadcasted to match the size of the bigger array. Now there is a catch. There is a very important thing to understand, that what array can be broadcasted and what array cannot be broadcasted. So let us say you have two elements instead of one. So in this case, what do you think what will happen? Well, we are going to get an error. So let us run the code and see. We are getting an error called as value error. Operands could not be broadcast together with shapes as 4 and 2. So the first array is having one dimension with shape as 4 comma, that is the first dimension is having 4 elements, and the second array A3 is having one dimension with 2 elements. So it will look something like this. Let me copy this. So copy this one, and the second one is 10 comma 10. Now this cannot be broadcasted to match the size of this, and the reason is, see, this is 4 elements and these are two elements. So in case the elements are different, NumPy will be confused that what element it needs to copy or broadcast to match the size of the first array. Should it use 9 or should it use 10, right? So this is how you can understand that if there is any sort of confusion, the broadcasting will not happen. And technically, if I talk about this, so if you have first array as shape of 4 comma and second array of shape of 2 comma, this cannot be broadcasted. Only if the shape is 1, this will be broadcasted. And let's say you have a array with shape as 4 comma 5 comma 6, that is it has 3 dimension, and the first dimension is having 4 elements and the second is having 5 element and the third is having 6 element, and the second array which you are taking is having one dimension with one element. So this can be broadcasted. What it will become? It will become 1 comma 1 comma 1 to match the dimension. That is, this will become a three-dimensional array, and then it will match the size of each dimension. So it will become 4 comma 5 comma 6, because there is no confusion that we just have to use that single element to match the first array. So let us see the example of broadcasting using multi-dimensional array. So we have a multi-dimensional array called as A2. So the shape of A2 is 4 comma 2. So it has four elements in its first dimension, and each element in its second dimension is having two elements. So let us just print the shape of A2. So print A2 dot shape and run the code. So you can see the shape is 4 comma 2. First dimension with four elements, second dimension with two elements. Now if you perform A2 plus A3, what should happen? So pause the video, try to guess the output and then play it again. Alright, let's run the code. So when we run the code, we are now getting the output, and what's happening is each of this element is added to this, right? So why this is happening? See, this time you are having two arrays. The shape is 4 comma 2, and the second array, which is smaller, is having the shape as 2 comma, right? So this time what will happen? It will first try to match the dimension. So 2 comma 2. So this is how it will look like when it becomes a 2 by 2 array, right? Now this time it knows that this is the element which it needs to add to this. This is the element which it needs to add to this, and also there is no confusion that this is the element which should be added to this and this. So this time instead of 2, this will make itself as 4, right? Because there is no confusion, right? This will be added, so this will be added, and next again this will be added, and this will be added. So the array which was just looking like this, 10 comma 9, will become a 4 by 2, because we are now able to match the shape of A3 and A2, right? So this might look like a bit confusing at start, but when you just practice it with different dimension and different values, you will be able to solve it. So even if I just introduce one value to this, let's say 10 comma 9 comma 8, this will not happen. This will be an error. So let's see why. Clear the console, print the value, and this is an error. Why? Because this time what you are doing is you are trying to match these two shapes. So in this case, first it will be 3 by 3. It will first match the dimension, and second it will try to match the elements. So the large dimension is not matching, right? So if the large dimension is not matching, there is a confusion. You cannot add 10 9 8 to 1 and 2, right? So I think you just got the idea of broadcasting. It might look a bit, confusing, but do not worry about it. We will create projects in future where we will be implementing this concept. So all the doubts and everything will be gone. And in case you just want to explore this too much, what you can do, create many arrays of different dimension, try to do the addition in between the arrays, and you will be able to get the idea of how this, broadcasting works. So we have covered the concept of mathematical operations and broadcasting. So if you are up to this point of the video, you deserve a bonus. And the bonus is that you will learn a very important concept which is actually used in a practical world in data science, which is called data normalization. So how we can perform data normalization in NumPy is, let us see this with an example. So I have created the program already, and I will just explain you the concept. Data normalization means convert your data in the range of 0 to 1. So if you have a data 50, 60, 70, 80, and 90, this is an array where the minimum element is 50, the maximum is 90. And if you want to convert this in the range of 0 to 1, and the data should be normalized, then what you have to do is you need to use the formula where you have to first decrease the minimum element from each element. So minimum is 50, so decrease 50 from each element, and then you have to take the difference of the maximum element and minimum element and divide each element from the created data, and there you will get an array of 0 to 1 range, right? So if I just print the value normalized data, so if we run the code, so the output is 0, 0 0.25, 0 0.5, 0 0.75, and 1. So we have normalized our data. So normalization is a concept where we, change the range of our data from 0 to 1. So this is a simple formula for it, and we can implement it using NumPy. So I hope you liked this whole video, whole concept of mathematical operation, and especially the bonus tip as well. So in this video, we have covered element-wise mathematical operation, broadcasting. We have seen some built-in mathematical function in NumPy, and we have covered the concept of data normalization as well, a little bit of it. So I hope you found this video useful for you, and if you did, and if you're new to the channel, make sure you subscribe it as well. And I will see you in the next video of this particular series.